Determine the derivative of each of the following polynomials. So quickly we want to recall that if we have a polynomial term f of x equals ax to the power of n, then we can find the derivative f dash of x by taking the power and multiplying it out the front, and then subtracting 1 from the power. So let's have a look at what that looks like. So for part A, we have f of x equals 4x plus 5, where this x would technically have a power of 1 on it. So that means that our derivative, f dashed of x, is equal to, so we have a look at the power, and we're going to multiply by 1, and then we're going to have 4x, and then we're going to subtract 1 off the power, so that will give us x to the power of 0. And then for the plus 5, we have that is a constant term, and the derivative of a constant term is simply 0, so we'd have plus 0 here. Therefore, the derivative f dashed of x is simply equal to 4 times x to the power of 0. However, x to the power of 0, or anything to the power of 0, is simply 1. So that means that f dashed of x is equal to 4. For part G, we have the polynomial 3x squared minus 7x. And technically there's a 1 for that power. So the derivative is going to be given by g dashed of x, and that's equal to, and we take the original power and we multiply that out the front, so we'll have 2 times 3x to the power of, and subtracting 1 off the power will give 1 here. And then we're going to add on, and we take the original power out the front, 1, and we're going to multiply that by the negative 7x, and then we're going to take 1 off the power, so that's going to become x to the power of 0. And we know that anything to the power of 0 is simply 1. Therefore, the derivative, g dashed of x, is simply going to equal 2 times 3 gives 6, and x to the power of 1 is just 6x. And then we're going to have 1 times minus 7, which gives minus 7. For part C, we have the function h of x is equal to x to the power of 5 minus 3 times x to the power of 4. So the derivative, h dashed of x, is going to equal, and we take the power and multiply it out the front, and then we subtract 1 by the power, so it's going to be 5x to the power of 4. And then we do the same thing with the next term, so we take the power out the front, and then we multiply it by the 3x to the power of 4 subtract 1, which will be 3. Therefore, simplifying that, we find that h dashed of x is equal to 5x to the power of 4 minus 12x cubed. Finally, for part D, we have y equals a half times x to the power of 3 minus 9. So the derivative this time will represent with dy dx, which is another notation to represent the derivative. And that is going to equal, and we take the original power 3, and we multiply that by 1 half times x to the power of 3, subtract 1 off the power will give x to the power of 2. And then for a constant term, when we derive that, we just find that that is equal to 0, so we're going to add 0 onto the end. Therefore, dy dx, which is the derivative, is going to equal 3 times a half, which is 3 divided by 2, times x squared plus 0, so it's just 3 divided by 2x squared.